So hello everyone, I'm Shak. I'm based here in Asia and we'll be talking about Megawatt Charging. So today is a Super Tuesday because it's CharIN Tuesday. The main topic will be about Megawatt Charging for electric and hybrid vessels, because in the marine industry, vessels are a major contributor to CO2 emissions, and when vessels enter harbors, are traveling along rivers, or are berthed close to cities, you have the problem that large amount of pollutants are pushed into the air. So to lower these emissions, electric and hybrid marine vessels are the way forward. And for e-vessels to really be commercially viable and be a good solution for operators, you will need at least two key ingredients. Is a megawatt charging system, and then also an advanced battery communication charging protocol. So therefore, we will go into more detail about ISO 15118-20. This is the latest communication protocol that came out in 2022. And then MCS, which is ready to be launched in a couple of weeks, officially, a couple of weeks. So we have 6 guests who will provide some good insights on how e-mobility on water can be successfully implemented. We have Maria Bos from Plugport. Maria, where are you? Hi, Dan. So we have Maria Bos. We have Jason Yo. Jason, where are you? Jason, hi. Hi, Maria. Hi, Jason. Hi. Then we have Jim Andriotis, sorry, from Cavotec. Hi. We have Sip from Maritime Battery Forum, and then we have Dan Knapp. Dan, okay, there you are. Okay, and then we have Peter Rampen from Damen, who will be sharing his experience building commercially viable e-vessels. So Peter will be talking first, but just to the audience, if you have any questions or during this presentation, please don't hesitate to put them in the chat function, and after the presentation, we will try to tackle them one by one. So Peter, the floor is yours. I'll go and switch off my camera as of now. See you later. Bye.
Okay, thank you, Shak. So good morning, everybody, and good afternoon or good evening even. So my name is Peter Rampen. I'm the Principal Research Engineer for Electrics and Automation at the R&D department at Damen Shipyard. I have more than 18 years of experience in electrification of ships. And about 10 years ago, I was already involved in implementing battery systems on board of hybrid ferries and also hybrid super yachts. Since more than 6 years, I'm in the Damen R&D department, and in these 6 years, we did a lot of work in electrifying our vessels. Maybe it's good to mention that I'm also a member of the Dutch Committee for Maritime IEC Standardization, so the IEC 18. The Technical Committee 18, and in this role I'm also a part of the joint work group, the joint work group 28, that is standardizing the utility connections in port, which also has a task force on working on standardization of charging connections. Today I'd like to share some our experiences on charging of vessels and how we think that megawatt charging system can help us in this challenge. First, let me have a few words about Damen. So Damen is a family-owned company building ships, but not only ships, also building components and for ships, and having ship repair and conversion shipyards. And the portfolio of Damen, the types of ships that Damen is building is very wide. So building from naval vessels to super yachts, from small workboats to very large offshore support vessels. Next slide, please. aim of DAME, one of the missions of DAME, is to become the most sustainable and connected shipbuilder in the world. And of course, electrification is, especially in the sustainability goal, one of the key technologies to enable this. And at the moment, also electrification is the only available technology to make ships really zero emission greenhouse gases. So next slide, please. We have already quite some experience in electrification of ships, starting more than 20 years ago with electric propulsion. At that time, still the energy was generated by diesel generators. But since 10 years, we're also implementing batteries on board of our ships. Next slide, please. And this started all with first with hybrid topology, so non-plug-in ships. But next slide, we also now have ships that operate fully electric, so ships that have a shore connection to charge the batteries. A lot of those vessels are still hybrid on board, so a generator as some backup or range extender, but we have also one project, one ship type that is fully electric, so no generators on board. Next, please. So the choice of choosing the topology, so the ones that you also see in cars, from fully electric to plug-in hybrid, is really depending on the location. Of course, fully electric is the most simple solution, but it's only applicable for ships with a very short range and a low power demand. And hybrid solutions is more applicable for more type of vessels, where maybe in the future the energy is not generated by diesel engines, but maybe by fuel cells or generators that are running on alternative fuels like methanol or other fuels based on hydrogen. Next slide, please. As I said, in the past, ships were designed based on power and the maximum power demands, but now because of the size and the cost of batteries, we design the ships much more on energy. So the factor time is in it now. So we're starting with the operational profiles of ships that can be really different from location to location, and based on that we choose the optimal topology, size the batteries, but here also the charging strategy and that is chosen. So where to charge, with what kind of powers, how often to charge. This is all part of the design, what's new compared to ships in the past. Next slide, please. We then look to the topology of, let's say, the schematic from, and in this case, not grid to wheel, but grid to propeller, as we call it. We have, because the grid side is so important also for the operational use of the ship, and our power demands are quite high. We have now also not only delivering a ship, but we also deliver the shore supply as part of our scope now. Next, please. So that's now also part of our scope, where we extend our scope of supply. Next, please. Now I want to show you a few examples of how we do charging our vessels right now, with some examples. Next, please. So this is the first example. It's a fully electric passenger ferries. We have at the moment 7 ships delivered, operating in the city of Copenhagen, and those vessels are charged on 3 locations with automotive chargers. And in this case, the power levels are about, I think my slides are disappearing. Oh, this is an animation of
the sound is switched off. Can you please switch it back on?
Yeah, that's something happened. It's now back again, I think. Okay, yeah. So the system is the power levels are quite decent. Let's say it's about 2 times a road bus. I think I don't know if it happened to me only, but the first station is switching a few times.
Yes, there is a lot of movement in the screen here.
Yeah.
I have lost. Okay. I don't see the video.
Okay. Now, and another example is a bit larger ferry. So the previous example is, let's say, power and energy about 2 road buses. But we also built some ferries that are a bit bigger. They have about 4 megawatt hour energy installed. Here we're using a 1000-volt DC bus voltage. In this case, when a constant DC voltage, so the batteries are connected via DC converters. And in this case, we're charging with about 3 megawatts. And that's an opportunity charge. So the ferry sails back and forth, and every time it's at the quayside of, let's say, at the ramp, the vessel is charged and the connection is made automatically. Next, please. And for this, we're using a very sophisticated charging connector developed by Stemman technique. So we connected the vessel to the grid on the bow. Next, please. And the third example is a hybrid, a fully electric operating tug. So the installation on board is hybrid, but it's meant to work almost 100% of the time, fully electric. Also 1000-volt DC system on board, about 1.5 megawatt of charging, 3 megawatt hour of batteries. And in this case, the charging time is longer. So for the ferries, the charging time is very short. So there the investment of an expensive automatic charger or automatic connector is good there, because in every minute you save by connecting the vessel, you can lower the charging power. But here the time is longer, so we use a manual connection. What you can see in the next slide, please. So for this, we're using the 4 parallel connections of the CCS2 plug, the HPC version. Next, please. What you can see here. And for supporting the cables, we developed also a kind of cable supporting arm to bring the cables easily on board. And totally, we charging indeed with 1.5 megawatts. So every cable takes about 350 kilowatts. Next, please. You see that. Can you run it? Yeah. So you see the test of the arm at our shipyard in Vietnam. So where the ships are built, the ship was fully tested first in our office. Not the ship itself, but all the systems on board in simulated test. And then on our shipyard, we tested together with the charging system as well. The ship is now on transport to New Zealand, where the ship will going to operate. But yeah, 4 cables is still doable, but if the charging power is increasing, then the number of plugs becomes too much, of course. So next slide, please. Of course, next to the hardware, also control is involved to communicate between the ship and the shore station, and also safety circuits are necessary. For this tugboat, but also other projects, we developed for now our own protocols, which are based on the IEC IEEE maritime standards for shore connections. That's the IEC IEEE 8005-2. What we adapt of, let's say, take as a basis, and also we take some inspiration from the automotive standards, but this is a very dedicated solution. Next, please. Next slide. So what I showed in the previous examples, that we do have a lot of charging solutions available at the moment, all still dedicated design, so it's still not possible to charge your electric vessel at different locations. or with the same charger charge different vessels. From the hardware, there is no really a standard, but also from the control point of view, there's not a standard. So what we think is that maybe the megawatt charging standard can help us in becoming a standard, because developing something in the maritime world will take, of course, years, because there is not that much going on yet. So yeah, before the standards are there ready, I think the demand is already there. So we hope that using megawatt charging can help us. Next, please. Next, yeah, maybe next as well. So if we look to the specifications of the megawatt charging, we see that it's quite interesting. So the power levels are close to what we need. There, of course, all communications and administrative layers are already there, and it's already designed for example, a vehicle-to-grid operation as well. Next, please. But it becomes, of course, with some challenges, because a ship is not like a car or a truck. The power levels on a ship are much higher, and the diversity in solutions is also much bigger than a ship. And small ship is, let's say, 10 meters, and we go up to ships of maybe 400 meters, each with its own dedicated system. We also have multiple battery packs, so there's not one battery pack, but at least two. And the power control on board of vessels is different compared to cars. What I said, the battery packs is also diverting. We're going from small batteries to very big ones, but also the power management for the battery management systems, communication protocols are all dedicated and determined by the battery manufacturers. Not really standards yet. Next, please. Another challenge we have is, of course, the EMC levels are, that we are allowed on board of our vessels are much higher than that are allowed on automotive applications. So that's something we have to work on. And of course, berthing and corrosion is a tension point, a point of attention, maybe where we need an adaptation. And another example is the safety philosophy can be different. On vessels, it's still required to have emergency stops on board and on the charger, while this is not part of the chargers we see used for the charging cars. Next, please. So to summarize, we see that megawatt charging ticks a lot of our needs, but still has some challenges. So maybe for the power levels, we need to be able to have some cables in parallel. For the communication, because we use different control methods, maybe we need to adapt the communication standards and power control standards. And of course, the standards need to be aligned with the maritime standards as well. Next, please. So we think the megawatt charging is very promising for us, and especially if we want to go to charging as a service, so that we are able to charge a vessel at different locations, and that with one charge you can charge different vessels. But some maritimization is required, and this is also something we want to investigate and work on together with the whole chain in this charging systems. I want to thank you for your attention, and I think at the end we have some time for discussions.
Thank you, Peter. I see there is no question coming in. Before we go to the next speaker, I just have one question about e-bunkering. You mentioned at a certain point you have an onshore battery buffer.
Yeah.
Why would that battery buffer be needed?
Yeah, because the power connection there was too weak. This is at a very remote location in Canada, and the power, I think the power availability from the grid was about 400 or 800 kilowatts, and we want to charge with 3 megawatts, so we use the battery as a buffer. But the battery will also be used as a grid support buffer. So, yeah.
Okay, good. Thanks. We'll come back later on. We go to the next speaker now, Maria Bos from Blackboard. She's going to be sharing her experience in installing and operating infrastructure for the marine industry. Maria, the floor is yours.
Thank you so much. So, yeah, if you go to my slides, I want to thank you for the opportunity to speak here today. So, being the CEO of Plug, obviously my approach will be a more high-level strategic related to the megawatt charging. But if any one of you are interested in discussing more technical details with us, I have lots of colleagues that are more than happy to participate in those discussions as well. So if you go to the next slide, Plug is a company that works with both shore power and charging for all types of vessels. So basically, we build this type of infrastructure for, well, everything from the largest cruise ships to the small leisure boats. And our ambition is to contribute to speed up the building and the construction of this type of infrastructure, and contributing with our competence, and also investing in this infrastructure, both in Norway, but also in other countries. And if you go to the next slide, our business model is pretty much the same, both when we talk about shore power and charging. We take fully responsibility for the whole process, from kind of figuring out what to build until it is in full operation. For the larger shore power projects, we will very much like to have a close collaboration with the port or the key owner. So our preferred model is to have a joint venture with the port. However, for smaller projects, typically smaller charging projects at this time, we also do this on a standalone basis, meaning that we both build, own, and operate the infrastructure, and then sell the energy as a service to the customers. And if you go to the next slide, this is an overview of our largest project at the time. So we have a collaboration with 13 ports around both Norway and also in Denmark and in the UK. Last year, the total energy sold to vessels through our infrastructure was 20 gigawatt hours, which is quite a lot. It saved around 16,000 tons of CO2. If you go to the next slide, these are the chargers, typically CCS type 2 maritime chargers that we have in operations around Norway at the moment. So it's 29 as a total. And yeah, in a few weeks, hopefully it will be even more. So we're continuously working to build a charging infrastructure around the Norwegian coast. And I would say that the typical customer for us today are professional customers, could be within the fishing industry, it could also be within the tourist industry. And as of today, we are able to serve these customers by using CCS and type 2, but as I will revert to, going forward, we will need more power, and the megawatt charging system will absolutely be something that we are looking forward to build where that is needed. So if you go to the next slide. This is a picture from the capital of Norway, Oslo, and Aker Brygge, where we have installed 13 maritime chargers. These are being used by Cruiser, which is a company that offers electric boating to like ordinary people. That can it's an electric boating pool, basically. So we collaborate with them and build the infrastructure where they operate. And if you go to the next slide, this is a bit further north in Norway, in the city of Florø, where we have installed a high-speed charger, actually 2 high-speed chargers for boats, that's 150 kilowatt chargers that are being used by electric boats on a daily basis. And this is actually also a combination charger, so we have 2 connection points on the quay, and then we have one on land where it's possible to charge a car at the same time, but the seaside or the boats will have priority always. If you go to the next slide, this is just an overview of all the things that we have to consider, especially working with shore power and in large ports. Obviously, if we need to add charging, as it said in some of the boxes here, the power need will increase. We do have some boats that are basically charging at our shore power connections today, but then they have the DC charging on board the ship, so they are able to use our AC shore power connections to charge the batteries. But obviously, going forward, we also think that in some ports it will be a good solution to have DC charging from the shore side as well. But I think it's also the previous speaker was talking about, standardization is an issue all over here, and obviously if we're gonna implement new technologies, standardization is always welcome. If you move to the next slide, we do see that an increasing number of vessels will need charging going forward. Here in Norway, we're working a lot with fishing vessels, looking into how we can make them fully electric and how to make the infrastructure to make that possible. We have our beautiful fjords here in Norway, where it has to be zero emission vessels if they are allowed to come in there going forward. And obviously, there will have to be a battery involved in that in the solution to do that. Passenger ferries has been mentioned earlier, and also within yachting, we do think that there will be more batteries, and we need to make the infrastructure ready so that they're able to charge their batteries while berthed. And we also think that other ship segments will follow. If you move to the next slide, this is the sort of the current maritime charging portfolio of products that we have today. So we have fast chargers, typically type 2, which is dedicated spots up to 22 kilowatts with power and load management. So typically for marinas, this will be a good solution. And it also allows for fair payments across the marina, which is obviously also an important aspect. And then we have high-speed chargers, CCS up to 200 kilowatts, and also mobile types of that. That is typically publicly available and scalable, and then you pay per kilowatt hour used. We also have a charging hub, and we have electric floating docks that we're working on as well. And obviously in the future, we would very much like to add the Megawatt charging system to our portfolio. And just to mention that safety is key, so the maritimization of this technology is really important going forward. If you move to the next slide, just want to mention, as I said, we're working a lot with the fishing industry and the seafood industry, and we would also build an infrastructure in the north of Norway to demonstrate how this industry can become at least emission-free by 2030. So that's really exciting, and I do think that the Megawatt charging system could be part of that. Next slide, please. yeah, to sum up, I mean, we are ready for the megawatt charging systems. Already today, we do see that fully electric passenger ferries and also for ferry charging, that this will be a good technology. Other types of vessels will follow. However, cost, volume, how much energy can we sell, and the time of charging is key in order to find the right technological solution. So when will CCS and AC be sufficient? That is obviously something that we will have to look into for each project. Next slide, please. Just want to mention we have a map on our website where you can go in and suggest locations where we should build chargers, publicly chargers, but also other types of projects are welcome. And next slide, if you want to talk more about charging or shore power, please feel free to reach out. Thank you very much.
Thank you, Maria. I was expecting a tsunami of questions, but it's pretty quiet for the moment. So I have a question for the CEO. You're an operator providing onshore power supply, and at the same time, you're also a charging point operator. Are you already breaking even as a charging point operator, or is most of the revenue coming from onshore power supply?
It's definitely most of the revenue coming from onshore power supply at the moment. We have a kind of like two types of strategies for the charging business. One of them is obviously building chargers where we know that there are customers. But at this time, it's also about finding the locations where we believe will be important going forward. So we will also build infrastructure where there is not a lot of customers today, because we believe in this technology and we build for the future. So it's a chicken and an egg thing, really. So we need to that. The lack of charging infrastructure should not be an argument for not going fully electric.
Right. Okay, good. Thank you. All right, now we'll go to the next speaker is Sip, and Sip is working for the Maritime Battery Forum, and he will be talking about containerized battery swapping systems and how to do it within his organization. What is the right strategy? So Sip, the floor is yours.
Thank you very much, Jack. Hi everyone, my name is Sip. I'm the Managing Director at the Maritime Battery Forum. And next slide, please. The Maritime Battery Forum is an organization promoting batteries in the maritime industry. I see the slide got messed up a bit, but so how do we promote batteries in the maritime industry? It mainly by sharing of knowledge and information through conferences, webinars, seminars. We have a ship register, which is an overview of all the battery powered ships in the world. And we organize a couple of collaboration projects where we bring together people from the industry to work on battery related challenges. We have a project looking into the development of shore power in the UK, a battery safety project, and a project looking into the standardization of battery containers. More about that later. Next slide, please. Then this is an overview of all our current members. We have 54 members at the moment, and our members are located all around the world and are all different kinds of companies that do work related to maritime batteries. So here you see we have Shipyard, ship owners, battery manufacturers, integrators, class societies, research institutes, anyone that wants to know more about maritime batteries, that wants to be involved in the discussions on how the technology is developing, is welcome to join the forum. Next slide, please. Then here you see two figures from our ship register. So on the left, the top figure shows the number of battery powered ships in the world in operation and under construction. I have to say here already that when I had to hand in the slides for this presentation, these were still the old numbers. We are constantly updating this, and now we're more around 430 or 40 battery-powered ships in operation, and even close to 200 in or under construction. But you see that it is, of course, nothing compared to electric vehicles yet, but it's definitely growing very, very fast. Now, most people think batteries are just for ferries, and yeah, ferries are the largest group of battery-powered vessels. They're easy to electrify because they're always going from A to B. You know where they're going to be when you want to charge them and when they have to be charged. But batteries are not just for these ferries. Actually, all or almost all types of ships can benefit from having a battery on board. And that can be bulk carriers, tugboats, research vessels, ro-ro vessels, platform supply vessels. But then, of course, it's not going to be fully battery powered in most situations, but the hybrid propulsion systems are really what the maritime industry can benefit from. And then at this moment, with diesel generator combined, but in the future with different technologies like hydrogen fuel cells. And next slide, please. Here you see an overview of the average battery size installed per ship per year. And in the first 5 years of last decade, you see that it was going up and down a bit, and that was mainly because of the limited number of battery-powered ships. But over the last 5 years, you see that there's a steady growth, and that in 2021, the average installed battery capacity per ship was about 1.6 megawatt hours. And these bigger batteries and more demanding operational profiles also require higher charging power. So that's why megawatt charging is really needed in the maritime industry. Next slide. Yeah, then here in the top figure, you see the location of battery-powered ships around the world. So this is just for the ships with an IMO number that we can track, but it's a large part of the battery-powered vessels that are sailing out there. The bottom picture shows an overview of the availability of shore power installations. And although you see that the largest group is in Northern Europe, marine electrification is a global trend, and we see shore power installations and battery-powered ships popping up everywhere. And therefore, a global megawatt charging standard helps with the adoption of maritime battery systems, but also with the adoption of shore power for ships, which is the easiest way to decrease emissions in and around ports. Next slide, please. Because yeah, nobody wants to or really enjoys plugging in 26 connectors when you want to charge your ship. Peter before me showed 4 plugs, which looks quite easily, but I'm pretty sure that if you have to do 26 plugs every time, you get a bit tired of it. Next slide, please. Then a trend that we're seeing a lot is putting batteries in containers. In the maritime industry, we're really used to shipping containers. And if you put batteries inside the container, you can use it for different types of applications. So you can use it as a swappable battery system for push boats or inland barges. You can fix the container construction to the deck for offshore applications. And you can even put the containers on the quayside and use it as a buffer for shore power installations. Next slide, please. So there are different types of applications, but these will also have to do with different regulations. The difference between inland shipping, offshore, onshore systems, and the difference between fixed and swappable systems require different regulations. And that's why we started our battery container standardization project. where we are identifying the interfaces between battery container and ship and creating an overview of the available standards. So we can use this to promote that the industry converges to a limited number of standards. And the Megawatt Charging system standard will help us, or help the maritime industry, to adopt these containerized battery systems on a larger scale. Next slide, please. So the MCS standard will not be the only standard and the one standard that we need for everything. There are many different types of applications which will need different types of charging standard, but it will help us to increase the growth of maritime battery systems and help us with the standardization of at least part of the containerized battery systems. And by helping us with these with the growth in system and standardization, it will really help to reduce the emissions in and around ports and for vessels all around the world. Next slide, please. So I want to thank you all for the work that you are doing with the MCS standard. And if you want to contact me, here are my contact details. Thank you.
Right, thank you, Sid. Quick question. I don't want to know how many megawatt is in 120-foot container, but how much there is a battery system inside of such a container weigh? And will it affect the design of the vessel? Because you're changing the center of gravity.
Yeah, so the amount of, or the capacity installed in one container depends a bit on what type of battery you use and what kind of auxiliary systems you want to have inside. If you want to have the power conversion or the cooling system inside the container, or if it's external. But indeed, these are quite heavy containers. And it's not for all types of vessels that you can at this moment put a battery container somewhere on the deck. You need to be able to have this location. So yeah, it's really depending on the situation.
Yeah, okay. It stays a puzzle. Okay.
Yeah.
Good. Thank you, Sid. Then we go to our next speaker, which is Dana from ABB, who will be touching on the progress that MCS charging equipment on the equipment, what is being developed at the moment, and when will it become commercially available, I'd say. I think this is a question that everybody's waiting for. So, Dan,
okay, I'll try to answer the question. Thank you, Jack, and good morning, good afternoon, and good evening, everyone. So thanks for the introduction, and indeed, my name is Dan. I work at ABB. I've been working in this industry now for 14 years, so quite a little bit of experience. And basically what I will show is the journey that we made as ABB from passenger car charging, which was initially, it was not possible according to a lot of people. Then it was possible. We went to fast charging of buses, and then we went to do trucks, planes, and then the marine vessels. So that's basically what I want to show today. So maybe if we can go to the next slide, and we can dive into it. Within ABB, I'm responsible now for business development. So that is also looking at new solutions. We're doing a lot in energy management, and megawatt charging is one of the topics I work on, but also looking into new business areas like the maritime sector. If you look at e-mobility at the moment in ABB, we're based in the Netherlands with the head office in Delft, but it's a global company. We have more than 1,000 people worldwide. This number is even already significantly larger. We're growing like very fast. More than 350 people in R&D. And we have sold more than 650,000 chargers worldwide. That's AC chargers, including what we do in China, but also 300 or 30,000 DC fast chargers. We're the market leader there. We're covering basically the entire world. We have installed and supporting chargers in more than 85 chargers worldwide. Yeah, so that gives a little bit rough of an idea on where we are as ABB on this topic. So then we go to the next slide. because I would like to give a perspective not totally from the maritime sector, because I think there you have a lot of knowledge already, but I want to show that the e-mobility sector and the maritime sector, they're converging, and there's two things I think where we can really come together and have a lot of synergies from. Yeah, so to give you an idea on where we are with passenger car charging, this is an example in Europe. There's a lot of operators. That's what they call today, a little bit like the conventional petrol and gas station sales. There's a lot of CPOs, charge point operators now entering the market, entering into service. An example is, for example, Ionity. They have more than 400 sites in Europe where they are putting and installing charging infrastructure. And that will even be expanded now to a significantly larger amount of sites. As ABB, we deliver roughly half or more than the chargers that are used at Ionity sites. And basically, it's a joint venture of BMW, Daimler, Ford, etc., Volkswagen, and Porsche, to ensure that their vehicles can also go onto the road and that their customers are being served, which is, of course, something you can also take as a parallel into maritime charging. Yeah, so if you have a vessel that's electric, it needs to be charged. So how are you going to arrange for this? And then also interoperability becomes key. So if I want to drive from one country to another, it needs to be the same standard. So we have a lot of experience here with charging with DC power 50 kilowatt up to 350 kilowatt. So the charger you see here has a power rating of 350 kilowatt and uses liquid cooled power. So the plug can still be handled by a regular person. So that shows a little bit what we do on that side. If we go to the next slide, then we have the same example or a similar example in North America. This is Electrify America. They are also installing the entire backbone of infrastructure for people to drive around throughout the United States. And again, here you see this is passenger cars. So interoperability is really key. Any car that you buy today, and you see more and more models coming onto the market, it's really growing significantly. And they all just need to make sure that you work on each charger if they're coming. So that's really a key topic if you look at passenger car charging interoperability. If you go to the next slide, then we go more into, let's say, business to business kind of application. This is maybe a little bit more to business to consumers. But here, this is in Qatar, where we'll have the World Cup by the end of this year. And they basically said, we want to provide the right type of transport, which is electric. So they converted their entire fleet of 1,000 buses into electric. And these are pretty harsh conditions. So it is, of course, a challenging project. And they wanted to have a supplier also that can cope with the cold at night, the heat during the daytime, and also the small particles of dust. And we are delivering as ABB the charging solutions here. So this, what you see in the middle, this big red thing is a pantograph charger, where we use up to 450 kilowatt. We can even extend it to 600 kilowatt of charging, but in this project it's 450 of charging in this kind of extreme environment. I believe we have more than 90 of those opportunities chargers. And then to the left of the bus, in front of it, you see a small box. There we charge with connectors up to 150 kilowatt. And we are delivering more than 1,300 connectors to charge this entire fleet. And what it basically shows is that a full transition can be made very fast. So this is in Qatar, the entire bus fleet is now fully electric. And of course, there's a political incentive and a technological incentive behind it. But this is actually happening. And the funny thing is, I've been heading the business for bus charging for a couple of years for ABB. The speed with what this is doing is tremendous. We've seen it with cars, we see it now with bus, and I expect the same will happen also in maritime. So don't underestimate the power of transition. Let's say once the technology works, when you reach a certain point of total cost of ownership, this will go very fast. So I'm very excited also for the maritime industry to go fully electric, because also there we can have added benefits for having a better and more efficient environment. If we go to the next slide, another topic which I think is quite exciting is air travel, so even aviation. So in the beginning, people didn't believe you could do an electric car. Then it was impossible to do it in an electric bus, and now people are saying it's impossible to fly. Also, this will happen where people will take a regional aircraft initially. That is what Lilium is doing. So if you go to the next slide, it shows a little bit how cool this can be. So it could be that you, for example, connect Manhattan with the airport of New York to make sure that people can get there very fast. But there's multiple applications of these kind of things. We're also working with larger aircraft, but then again, also you need to have more higher power. If you look at these systems, they will be charged with anything from the existing chargers with 350 kilowatts up to 1 megawatt with the MCS charging standard. Yeah, so it gives a little bit of an idea on where these standards are being applied. So again, standardized solutions or standardized charging connectors and communication is important to make sure that you have some sort of interoperability between different types of planes or whatever on a certain site. And then I come a little bit into MCS, so the Megawatt Charging Solution, which is basically, oh, yeah, okay, never mind. Just leave it at this slide. But basically what you see, okay. So you have a truck charging, that is especially where it started out. So the truck OEMs basically said, okay, we need to have more power than this 350 kilowatt plug that we have today with liquid cooled power. We looked at how we could reuse the same connector and the same form factor to have more power over it, but we came to the conclusion if you really want to go for 1 megawatt or 2 or 3 or even 4 megawatt, you need to do something else. And so the pins became a little bit bigger, also in terms of safety and how you can handle this plug. It was decided, let's go for a new design, and that is then the MCS. So it's a different type of plug, but you can still hold it with one hand, let's say, and plug it in. Which you also see on the picture here on the top left. So if you then look at the development for the megawatt charging system, there's a couple of things. So it was already shown. Today it's decided megawatt charging MCS will have 1250 volt, 1250 volt and 3000 amp. But still the exact specifications need to be decided. So as CharIN, we made a very nice, let's say, framework on how MCS will look like, but in the end, in the local standardizations, it needs to also be embedded and approved. So this is a process that typically takes a few years. I will explain a little bit more about this. And also this goes hand in hand with the type of vehicles that will come out. So we have the trucks driving this, but we have aviation playing a role, and we have maritime playing a role, where already there was a few phrases, okay, we need to have a little bit of maritimization. So what we have today is we have CCS charging 160 with non-liquid cooled cable up to 300 amp and 350 kilowatt with 500 amp. We're doing various maritime projects already with this kind of technology, but we see clearly the requirement for more. So basically this year we're coming with the thing in the middle, which is C samples. So this is up to 1000 amp, which means that we can charge vehicles with this. But this is not something we will do in the public domain yet, because the standards are not there, so you cannot really certify against that standard as long as if it's not published yet or not official. So we need to make sure that it is safe working technology, and that it also complies to certain standards that apply in that certain region. What we're working on is with various OEMs, so vehicle manufacturers and vessel manufacturers already. And then you see on the right side, 23, 24, that's really when the ramp up starts for the larger trucks. I think the truck industry is really driving the MCS standardization for the big piece of this. And I expect, if you see the announcements by 2024, that the majority of truck manufacturers will come out with MCS trucks. That's typically the announcements that you see today. There will be some projects sooner already. I can also give some information on that, but the time is maybe not sufficient today. But please reach out if you want to know more. But that's typically 2024 when I expect that MCS will be commercialized, let's say. But then I'm still talking about MCS up to 1000 amp. That is what the use case today is for trucks. If you go charge with 1000 amps, you need to cool the cable on the charger side, which we already have experience with as ABB. But you don't have to cool on the let's say vehicle or vessel or aircraft side yet. So typically it doesn't have to be cooled, but if you go beyond the 1000 amp, the inlet needs to be cooled, which of course is additional technology, which I think will take a little bit longer than 2024 to be really commercialized. But that's something I see today in the market. I also see there are some challenges to get the technology fully operational, and this is a challenges that we anticipated on. But I also see that there's a strong interest, and that also drives the uptake and the speed of development. So this is not carved in stone, but it gives you a little bit of an idea on where we are regarding development of the MCS charging system. If we go to the next slide, then basically you see the main challenge here is we need to have commercial vehicles that are available, but also the standardization process is key. So as ABB, we started in the Netherlands in 2010. You see a very small picture where even the print still came out to open and inaugurate a charger because, wow, this was something totally new, and it came sort of out of space. It was totally evolved. What the connector he is using is a really big industrial kind of thing, like you currently maybe use also in the maritime sector, and he really had to plug that in a kind of funny way. And quite quickly after that, you had the demo organization coming with a standardized solution. 2 years later, we had CharIN doing the first CCS charging. So those were two standardized connectors which ensured interoperability, which also ensured that you could do quite easily CE or UL certification or whatever was needed in that specific country. And then from there we go to the right. In 2016, we had the first bus chargers where we had the first pantograph charging system. What we did there, we reused what we already had for CCS based on the communication protocol. So ISO 15118 was being applied, but then the connection mechanism was not the connector, but it was a pantograph with 4 poles. So that's also how you could look at this. You could say we use the MCS connector, or you can say we use the communication technology and we use a different plug or connecting device, depending on the use case which you will have with your specific vessel. If you then move on to the right, you see that it scales up, trucks become involved. We see energy management becoming more and more important. We already heard that a grid connection of 1 megawatt or 1.5 is not always easily readily available. We see more and more sites that will have more and more chargers, or they will combine it with solar batteries or whatever. So you need to start applying energy management in a clever and good way, so that you have a good total cost of ownership in the end in order to make your investments. And then we have indeed also the development of MCS, the Megawatt Charging System for electric trucks, aviation, and the maritime sector. If we then go to the next slide, and I think that's the last slide of what I will be telling today. If you look at the marine sector, what is clear, there's a quest for decarbonization. Yeah? So basically we need to reduce some of the emissions, that's very clear, but I think also in terms of efficiency, there's much to gain there if you go full electric. So that's really an exciting opportunity. So vessel electrification and right with that, it comes with shore charging. They present very attractive possibilities, and it will fly in the industry. Or maybe I should say float. I don't know what is the best wording in the marine sector. As ABB, we are highly active in the marine and ports industry. I would not say immediately market leader, but we are very present. We have a lot of technology that we bring also into this domain. We have also the support network for this. So we are very capable and we know what is going on there. So we work together, or I work together a lot with my colleagues from the maritime marine and ports to see, okay, what do we need to do and how can we make sure that our solutions fit together and how we can also support it in the field. We're the global market at ABB for e-mobility, so that helps a lot as well in terms of technology, but also in knowledge, support, standardization, etc. And like we already discussed today, I think the international charging standards, they are key. So I really encourage or plea for, let's reuse what we already have in terms of safety, reliability, interoperability, but also in terms of cost efficiency. Don't reinvent the wheel. In the end, what we will see, if you have charging equipment, you will need to have a grid connection, which might not be sufficient. So you probably need to share the infrastructure at some point in time. So interoperability will play at a certain point a role as well. And the benefit that we bring with also this technology by reusing, let's say, ISO 15118 or the Megawatt Charging standard, is that you can leverage on the existing volumes that are already happening in the automotive industry. So it doesn't have to be a full copy, but the volumes are so much bigger, which makes sure that you have a very attractive proposal, I think, also in the maritime industry. And whether this is CCS or MCS, or whether you only use certain protocols or certain power platforms, that remains to be seen and will be based on the use case that is given. So with that, I come to the end of my story, at least. Chuck, thanks a lot for the time, and thank you for listening. You're muted, Jacques. Most likely you have a question or you want to
Yeah, we have a question from Robert Dool from Shell, because
Okay.
you are mentioning that the heavy-duty truck industry is pushing the MCS standard or the MCS rollout of infrastructure. He's wondering if the marine and the aviation industry could be the trailblazers for these high power, high energy systems, and then later on trickle down to the heavy duty trucking industry. Because we are working most probably in the marine industry and in the aeronautics industry. Maybe the volume is smaller, but the how to say, the demand, not the demand, but it's more urgent maybe than in the trucking industry.
Yes, so I'm not saying that, so I think it's happening both. So I'm not saying that the truck manufacturers are only pushing, but they are pushing a lot, and they already initiated the MCS charging standard. But what you see is that the aviation industry is now involved, the marine industry is now involved, and so basically I think it is going currently in parallel. But I only say that there's a big push from the truck OEMs, and I think it's good that as a maritime sector we also jump into it. So I really welcome that, but in the end it's also about volumes. And what I see now today in the maritime sector or the marine sector, it's still quite fragmented. There's different types of charging solutions, different type of connection mechanisms. So I think it's also as a sector ourselves to make sure that we organize this in a smart way, and at a certain point say we go in and move into this direction, because that will really help to make it fly.
Yeah, you mentioned those C samples. Is that something that can be upgradable later on, or it would be too costly?
No, it's a principle. Of course, what you don't want to do is have something initially and then after that throw it away. So in how we work as ABB, our systems are modular, so that means that you can install it now, and at a certain point you need to make certain changes. And then comes the trick: what is the certain part, certain changes? And this really depends on what are the changes made to the MCS protocol and the MCS standard in the coming 1 to 2 years, which are based on the standardization protocol process. And this is a process where basically as CharIN, we've made a proposal, but now different institutes like ISO, IAC, etc., they need to say, yes, we agree with it, but there's all kinds of members that can vote. And if it remains the same as we have now defined within CharIN, it's a straightforward one and you can still reuse it. But if we have additional requirements or small changes, this is the real big trick. And of course, it's very difficult for us to say what will happen in the coming 2 years exactly. We have seen this with Sharmo, we have seen this with CCS liquid cooled cable, we have seen it with pantograph charging for buses. And that gives it a little bit of an insecurity. And that's really key for the industry to move on there and remove that security for the market itself, because then basically you open up the gate for people to invest in the technology to develop it, but also to procure it, install it, and then you can create a volume, and then it becomes attractive, and then it starts to fly. So the standardization part in that sense is really key to make a decision. This is what it will be, and then it will go.
Yeah. Okay. Good. All right. Thank you, Dan. We'll come back later.
Thank you for the time.
With more questions. Yeah, thank you. So now we come to Jim Andriotis from Cavotec, who will be touching automated charging systems in the marine industry. Jim, the floor is yours.
Thank you, Jacques. Hello, everyone. Happy to be here. So a bit of a background on Cavotec here. We have been in the electrification industry here for over 40 years, and we come from our background in ports and maritime and in mining. And for us to be involved with MCS has been a big step. You know, we've been talking to a lot of our OEMs about charging now since 2019, and they were always talking about power levels above what a CCS could do, right? When we get into mining and maritime, it was never a conversation with our customers anyway about 150 or 300. It was always about what can we do at 600, 1 megawatt and up. Jacques, next slide, please. So what happens here, you'll see the connections on the screen. On the right is a connection that can do up to 5 megawatts. On the left is a connection that can do up to 8 megawatts, depending on the implementation. But for us, it was about how do we enable high power charging of a lot of these vessels without going to these very large mechanisms, right? But going back to a little bit what Dan was saying here, the segregation, the fragmentation in the industry is quite challenging. So that's one of the big challenges that we always face as Cavitec on implementing connection technologies and charging systems. Because when you go to a different location, you have a different solution. And it comes down to a different wharf. What does the quay look like? What does the tide look like? So you're going to have a mechanism that can get a connector out to a vessel reliably based on where the vessel actually sits when it gets to wharf. Different vessels. One of the challenges we've also faced as part of the MCS committee is where do we put the charge port location on trucks? Well, the same conversation is now happening on the vessel side. That discussion is had during JWG 28, where we say, where do we put a port on a vessel moving forward? Do we standardize it? At this point, it looks like that's not going to be possible. So right now, the ports are in different locations. Either they're on the nose because it's a ramp style vessel, or it's on the side because you have a key available. So again, we're starting to face where do you put the charge ports and how do you standardize that? And then, of course, the last piece is the different connections. Whenever you would have a different power level, you would be asking for a different connector size to connect to the vessel as well. So it could be something from a 600 kilowatt, it could be up to 5 megawatt, right? But the connectors scale quite differently. And also the cables going to the connectors are quite different because of the power level differences. So what happens is it changes both the size of the funnel on the vessel or on the machine. It changes the size of the connector. It changes the size of the structure on the shore side. So there's a lot of variability here from the wharf to the vessel to the connector on what each project looked like. Next slide, please. An example of a couple of places where we have automated connections is the Ampere, which was a very early example of automatic charging for e-ferries. A lot of things that drove it, of course, are the typical e-ferry requirements, which is short turnaround times and high power charging for a very short amount of time. In this case, we had a fairly large tide as well. And there wasn't a positive restraint elsewhere for the ferry. It was usually just steaming into the ramp to hold it in place while allowing passengers to disembark. So in this situation, we solved it with two sides here. We have the automatic connection, and you can see the yellow cables going down vertically into the slot there and the pocket that opens on the vessel. And that's where we charge automatically. And then we have there on the bottom right, you'll see our moormaster unit, which actually holds the vessel in place. And it's a vacuum system, right? So the vessel comes up, we extend out, and we hold it with a large vacuum pad. Now, in this case, it was kind of killing the automation problem, which is how do you make automation of an electrical connection repeatable? You make the position of the vessel repeatable. And you're able to do that by securing it with the moormaster. Not all ferries are going to have the space or the freeboard for moormaster. Not all ferries will need it because of the ramp chart, the ramp types and the quay sides, but in this case, it was a big enabler for automatic connection for charging as well, because it allowed the vessel to be secure and stable as soon as possible. Next slide, please. So this is our APS that's located down Akerbrug in Norway, in Oslo. And again, as always, the short turnaround times, quick connection. And you can see this is a different type of system. It's the pillar on the right, and you can see the connection box that actually travels vertically up and down to be able to adjust with the vessel draft location. This is just a parking position so that it's out of the way. But in this case, this is a nose-mounted connection system. So the vessel comes in and we connect on the nose, and we charge that way. Again, in this case, we had to keep a fairly small vessel footprint. So the funnel is quite small, the connector is quite small, and it allows us to be able to connect quite easily. But again, you can see here the system that is used to get the connector to the vessel is quite different from the previous slide, which was a side-mounted drop from the top connection. This is now a vertically rail-mounted connection system that allows you to connect horizontally to a funnel. So it's a bit of an example. And you can see the other one was in a fjord outside in a remote area. This one is in a downtown location close to a lot of pedestrians and a lot of traffic. So there's quite a few differences in how you implement the connection system here. Next slide, Jacques. So we've got a lot of lessons learned here at Cavitec on how we were able to electrify other industries, right? The big one in relation to maritime is obviously AMP, shore power. We helped drive that standard connection for vessels to shore power while docked. There was a lot of work done on the west coast of the US and globally on being able to find a standard connection for when a vessel comes to a wharf, instead of having to let it run as generators, we can plug it in electrically. And we were able to help support standardize that connection. And already we're seeing huge dividends in pollution being reduced out west and globally. And now, because we have a standard connection, you're starting to see it scale, right? And you're starting to realize that a vessel can go to multiple ports of call and be able to plug in all of them because the connection is standardized. Right? Aircraft connections, this is another big role we used to play here at Cavitec, where every time an aircraft comes up to a gate, it's the same connectors. The 400 Hz connectors are standardized globally at every airport, at every gate. You know, it allows the scalability again of an aircraft being able to turn off its APUs, right? So these are two very good examples of what a standardized connection can do for an industry. So next slide, please. So of course, this is leading to standardization here for the maritime industry. And the way we like to see it, it really is the path to accelerated electrification, right? The interoperability, so you can plug in at multiple vessels, at multiple wharves. You know, if you have centralized locations where you have different ferry operators coming in, they can all use the same hardware to be able to charge. And I think this is a really important thing to remember, that it's not only about the connection interface itself. You know, MCS is going to have a standard shape, right? But it's also you're able to standardize the back end. For instance, your chargers, your grid connections, your containerization, these all become much more modular to be able to have the same solution you've used in one place, be able to move to another. And this allows the industry to become very scalable, because no longer do the charge system manufacturers have to create onesie twosie applications. They can do, let's say, a set of modules that can be used in different types of industries, be it car, be it truck, be it maritime, be it mining, right? So being able to scale because of those similarities between the industries is really key. Next slide, please. Jacques, next slide. Oh, looks like we lost it.
Yeah, well, hi, yes, Jim. Hello.
There we
Jim,
go.
are you there?
Yes,
Okay.
I am. Can you hear me?
Yeah. No, there is some, I'm not controlling the slides.
Okay.
I see there was a problem.
All right, no worries.
Okay, we're back. Yep.
Thank you. So we ended up going with the Megawatt Charging standard, and our path to going towards MCS and starting to include it in our future systems came from the industrial side, where back in 2019, we started, like I said, having conversations with our OEMs, and each OEM said to us separately, without being in an industry group at a time, we would like a connection for charging, but we want to make sure that we can charge our competitors' vehicles, or that our competitors' charger can charge our vehicles. They already saw it as an industry that it would be important for them to be able to be interoperable, because if it wasn't interoperable, then they would all be selling their own little moats, right? And they knew it wouldn't be able to be scalable as an industry, and the industry wouldn't accept having different moats and different charging platforms and protocols and connection types, because it just wouldn't be feasible, right? Think about the spares on the back end, think about the requirements and the procedures for each one. and the number of different chargers you would have to have in one location. It just wasn't going to work. So at the time, Cavitec took it upon itself to start, let's say, investigating what could be used as a standard connector for charging of industrial vehicles like mining or maritime. Now, Cavitec has a long history in industrial connectors. We'd already do the connectors for mining in many cases. We do the connectors for the shore power, right? So it was a matter of, do we go with one of our standard style connectors, or we say, all right, this is what we have already. Here are the pin types. Here's what we need to push through it. Or do we look for something else? And this is what led us into the MCS, because we started looking at the CCS1 and CCS2 platforms as a, how is it done elsewhere? And now we've been part of the group for almost 2 years and developing an MCS connector and charging systems. And it makes sense, right? It's a single plug that can do 3 megawatts. You can see here that it meets a lot of the industry specifications already. The big one here for us is also communication and being able to have that interoperability. It's already bi-directional. You know, it's a powerful system. And I think the point here is that you see the gentleman holding the plug. This is supposed to be manually controlled, or at least capable of manual control as well, right? So Jacques, if you, or Sammy, can you go to the next slide, please? So what does it do for maritime charging, right? We also recognize that maritime charging most likely will not be a manual affair when a vessel comes in, especially on the larger ferries, maybe on the smaller water taxi situations, or these little high-speed ferries. For instance, the ferry that was shown in an earlier presentation of 26 connections. You know, this is very easily going to be still a manual connection, or for tugs, right? But also, it's going to be also heavily automated as well, depending on if you even have shore personnel, right? So the great thing with MCS is it brings you a range of power levels you can use. 1 megawatt, 2 megawatt, 3 megawatt, you can possibly run in parallel as well. Like Dan said, the standard is still a little bit open, and there's still a few things we have to work with, both on the standards committees as well as on the vessel manufacturers, on how will we implement this on the vessels. But still, it gives you a flexibility on your power levels through a similar interface. It's light and compact. I think that's important, like I said, not only for manual, but for being able to automate the connection as well. Because all of a sudden, these large structures become quite small again. And being able to get a light connector out to a vessel, to a plug, is much simpler than moving 4 large cables with a large connector to a funnel. And in the end, you also have the interoperability. You want to be able to plug your vessels in anywhere. And having that flexibility on where your vessels operate is going to be a huge plus. And that's it from me. Of course, any questions, we can speak about it during the session. Thank you again. Jacques, I think you're on mute.
The cable length. That always comes back, because in the marine industry, the cables are much longer than in the automotive industry, or maybe also in the aeronautics industry. So what is the solution there to avoid this extra cost and maybe extra cooling systems?
So whenever we always looked at MCS for maritime, it was always, we were looking at it around these big systems that we have already, right? And just based on the size of the system, it was creating the need for a lot of cable length. So I think a lot of the challenges with cable length will be handled within implementation, right? There's going to be ways where we're able to keep that cooled section of cable short enough where we can use MCS and run standard style, let's say, cabling up to that point, because you only need the cooled cable at the point where you need it to be flexible, right? From then on, right, you can run more fixed. So I don't think it's that big of a concern at this point. I think the number we're always talking about is 10 meters of flexibility is what we really need, and we'll be able to meet all our requirements.
Okay, good. Thanks, Jim.
Yeah, no worries.
Now we go to a complete different subject from Jason Yo from AutoCrypt. And it's an often overlooked subject, but I think it's extremely important. And this is about cybersecurity in the marine industry. Even EMSA, the European Maritime safety agency, when we talked to them, the first point that came up was everything needs to be cyber secure. So here is the magician, Jason Yu, who's going to talk about cybersecurity.
Thank you, Jack. It's a pleasure to be here. Thank you to CharIN and all the event organizers for having me today. And thank you to all the panelists. There's obviously a lot of exciting things happening in the e-vessel industry, and it's really moving along. Many of you might be wondering why cybersecurity, and I think probably the way I look at it is just, it's not only charging that's happening, but there's a lot of data exchange that's happening in these sorts of charging infrastructures, and 15118 kind of opened up the wave to be able to do that. Now you might be wondering, why would they add on another layer of things that need to be protected? Well, a lot of my fellow panelists talked about interoperability. They talked about scalability. They talked about megawatt charging. All of these different components that the technology will bring us does require some cyber change, does require data exchanges, and therefore cybersecurity. So I'll go through that very quickly and kind of lay out some principles for the charging industry that we've picked up from 15118 for EVs, and kind of share what we're doing to help connect the vessel more towards a back end and with other entities out in the real world. Next slide, please. A brief word about the company. We specialize strictly in automotive cybersecurity, fleet management solutions, anything related to transport. We have over 200 plus employees, and we're opening offices all over the globe to be able to support different stakeholders who want to bring cybersecurity into their automotive and transport solutions. Next slide, please. So the cars being connected. Now, when we talked about cybersecurity, I don't know, maybe 10, 15 years ago, it was all about defense. So blocking attackers. And while that's still an important part of what cybersecurity is, in my opinion, what it really means is to bring trust, and then by bringing trust into all of the communications, we can increase the safety and safety from harm. So with cybersecurity experts that have been in the industry for a very long time, we provide comprehensive and end-to-end solutions for all of the different connections that the vehicle has. Next slide, please. We could skip this. We're lucky to get some industry recognition, but next slide, please. So let's get into it. We just saw a car and all the connections that it has. When we look at boats or vessels or ships, we see the same kinds of connections. You see the telematics connections. Some of these vessels are going to be autonomous, which means that not only does it have to have sensors and radar and LiDAR and that sort of technology to get a good understanding of its immediate environment, it also needs to connect with other vessels, other bayside units, I guess you can call it, fixed infrastructure that sends out messages to the vessels. And there's also going to be mobility security through mobile devices, the captain and crew, and also the area that we're talking about. If you press it one more time, I think we'll highlight the mobility security for the charging component, which what most of us are here gathered here for today. Next slide, please. So when we talk about general principles of cybersecurity, the first thing you want to do is encrypt all communications data. So that, and the idea behind this is that so that nobody else can open it up and manipulate it or steal any of the information that's going back and forth. In this case, it would be between the vessel and the charger. And we're trying to avoid the manipulation of data. And another way of looking at that is to increase the integrity of the data, which goes back to what I was saying earlier, which is we're really trying to assure the trust that we can have, so we can trust all of the messages that are going back and forth. Now, in ISO 15018, TLS encryption is used for data communications between the EV and the charger. We think that something similar can be applied here between the ships and the charger. And it's very tempting to look at just the vessel and the charger, but we also have to remember that there's a back-end IT network that's communicating with all of these, because everything is becoming more lighter, including the vessels, the chargers. They have more software in it, which means that there's going to need to be a back end that needs to be secure as well. Next slide, please. And this is a really key component. It only needs to communicate with trusted actors. What this means is that if we send an encrypted message from, let's say, from the backend infrastructure to the vessel, the vessel that the message is being sent to should be the only one that can read and decrypt the messages and send messages back. So the infrastructure needs to trust all of the legitimate endpoints that out in the field, and all of the endpoints need to trust the backend infrastructure. In order to do that, PKI platform, which uses digital signatures and security certificates, can go a very long way in order to assure that the messages are only being opened by those or the endpoints that are supposed to open them. Next slide, please. And of course, there's a lot of data that's going back and forth. It's no longer back in the internet era. Everything stayed within the network. Everything went out through the web, and we see all the attacks and hacking that happens in that area. What we need for this area is for electric vehicles, electric vessels, is that all of the data that's going to be transmitted back and forth, we need to be able to handle that in a secure way so that there's no leakage of private information. In this case, unlike the internet era, can have some real dire consequences in the real world. There's a variety of different ways to do this. For AutoCrypt, we incorporate blockchain technology to store and utilize the user data for our mobility services. But the idea of preserving the privacy of the data is going to be a huge issue going forward. Next slide, please. The next slide is going to deal with the platform. What do we do with all of these, the three principles that I talked about before? We need to be able to share the trusted platform with service providers. So what this means is that if you have this kind of a secure communication channel where you can trust and be assured of data integrity, you need to be able to get more trusted players to get into that platform to be able to provide different services. A mobility operator in the EV charging infrastructure is a great example of that. They're not necessarily within the OEM, they're not involved in the manufacturing, but since they're providing services for the charging services, they need to be a part of the platform as well. So to encourage all of these different services in the future, need to be able to share the trusted platform for service providers. Next slide, please. I'll just go through what have we been up to. So we're looking at all of these different connections, and of course we're continuing to provide a trusted platform for vehicle to grid, and we're working on that using the experience that we've worked with ISO 15118. We think it's going to begin with plug and charge kind of a technology, then to wireless, then to bi-directional charging, all of which is going to need the sort of encrypted communications and endpoint authentication. But in the meantime, we're working on vehicle to device technology to create trusted communications between the mobile device and the e-boat for recreational boat services here on the southern ports of South Korea. And on the Jeju Island, which is off the south coast as well, the e-boats are becoming a part of multimodal mobility services. So we're involved with that to be able to not only provide safe mobility services for the people who visit Jeju Island, but also to be able to use the user data to provide better services in the future. Next slide, please. So when we're talking about 15118 for e-vessels, a lot of it is prognostications, admittedly, but like automobiles, I think the maritime industry will incorporate electrification and connectivity, and therefore will need cybersecurity principles of encryption, authentication, and privacy. That has to be built in and maintained and monitored. I think that 15118, we've been involved with them for 4 or 5 years, and it's a great roadmap to see how the electric hybrid marine charging can incorporate future technologies in a safe way to assure trusted communications and data integrity. Thank you very much.
Thank you, Jason. One quick question. I mentioned EMSA, the European Maritime Safety Agency. You have the Korean counterpart, KOMSA. Mm-hmm. Are you already working with them on cybersecurity in the marine industry?
Yeah, absolutely, because you know, they need help getting their back-end infrastructure ready. They're trying to lay out infrastructure out in the real world, and everything kind of develops from consulting projects to pilot projects and to commercialization. I don't think we're that advanced yet as far as we are with EVs, but it's certainly we recognize that it's because of the costs involved here in terms of safety and all the monetary costs of running a safe system. We're working closely with them to consult them in order to be able to for them to have the system on the back end and out in the real world.
There's a question from Shell from Robert Dool. He's wondering if the PKI requirements in the marine industry or in the aviation industry would be different from those, let's say, in the automotive industry.
No, not necessarily, because I mean, PKI has been around since the 1970s. It just happens to be, you know, that it applies really well to IoT technology to be able to trust the endpoints that are out there. I think we have a good roadmap to build out the back end. Certainly, there's going to be certain specific needs for this particular industry, but the principles of having a root certificate authority and having sub-CAs that are under that remain the same.
Okay, good. Thank you. Keep your camera on. Let's ask all the other speakers to come online, and we will have a quick panel discussion where possible. Thanks. So I'm just looking what are the questions that are coming up. I have one question that actually for the presentation of Maria. Let me see, where is it? Yeah, there was a slide where you mentioned 29 public chargers was shown on a map, and wanted to know if are these chargers only for vessels, and which vessel type are they serving?
Yes, well, there's a combination. Some of the 29 chargers are both for boats and cars. That's a great way of building this type of infrastructure when it's quite immature for the boating side at the moment. But the vessels that typically connect are from the seafood industry, service boats that are used in that segment. Also tourist boat like rib safaris, things like that, and also just smaller leisure boats, for instance, from one customer of ours that I mentioned, which is an electric boating pool that offers like memberships to access electric boatings, which every one of us could do. Yeah, so different types of vessels, but quite small vessels at this time. Yeah.
Yeah. Peter, a specific question for your side related to the corrosion issue. I always thought, actually, from my point of view, that there was always these cathodic protection systems that are in place on vessels, but you still mention it for the charging. Is there something special happening that creates corrosion?
Yeah, because if you connect the ship to the shore, you get the interaction between the shore side and the ship. There can be different materials, especially if the ship is built by aluminium. And so that's one problem. And the other problem, of course, if you're getting leakage currents from your system, it's really accelerated corrosion, and of course, cathodic protection will not work anymore.
And is there any solution at this stage?
Of course, having an IT system works well, an insulated system, that there is no way of that there is current flowing through the ship, that the power is only via the cables. And have a good earthing philosophy, that's important. So there are ways to.
And now we're coming to some
automotive for vehicles, so that's something we have to find out. Can it be done in the same way, or do we need especially?
Now we're coming to a point that probably is also being discussed in the IEC 80005 and the Joint Working Group 28, is about the IP ratings. And I would like them put it towards MCS and maybe the charger. Is there anything that is required in the marine industry which is different from the, let's say, the land or transport in the land transport industry for IP ratings? Now I give it to both Jim, Peter, Dan, maybe Sip, if you have any input on that.
I think there is not that much different. Maybe the only difference is that you're often in a more salty environment. It's both outside.
Yeah, I was gonna say
I can concur. I think typically what the ratings of connectors are today is IP44 or IP54, I fully agree with Peter. The salty environment is more challenging, but of course you should not hang the cables in the water. That's not the right idea. But even with a little bit of ingress, you can still charge. So with rain, etc. But I wouldn't hang them in the salty water. That's not good for the cables.
Yeah. Okay. Any other point on this topic? No. Then there was a question about AC and DC charging for marine vessels. From my understanding, the question is about AC charging. So AC connection to the vessel, where then you have all the converters on the vessel that then do the battery charging on board, or having the charger onshore. What are the advantages and disadvantages of these two ways of charging for marine vessels?
Yeah, I think I can maybe answer that. We look a lot in this question as well, and it's a bit depending on the vessel type. So the smaller vessels, there is not that much room to install the chargers on board. So that we always choose to go for with DC on board. Of course, for larger vessels, things like cruise vessels, something Dam is not building, but they already have a large power connection to supply the vessel itself. When the vessel is on the quay side, the power consumption on the vessel itself is already a few megawatts. So then you can use probably the same connection for also charging the batteries, and then you have the charging on board, because you go with high voltage batteries will not be in high voltage batteries. So that's there you will get the conversion states on board. So I expect for the smaller vessels that you go with DC and often also charge the batteries directly. For larger vessels, I expect that the charges will be on board. Go with high voltage on board.
Yeah, I was going to say the same thing as Peter, that it's all about the weight really. Once you get into these smaller vessels, they want to have any of that weight they can off the vessel. So they try to go DC to the vessel. But we're on the same side where we say once you get larger, then you start going back to AC, just because of some of the power levels that you're looking at. And then they have the space on the vessel as well to be able to put on the AC DC conversion, and the weight isn't as big of a factor. It's finding where that cutoff point though is, which is the tricky part of what point do you shift from DC to AC? Is it vessel size, is it power level? But it's always going to be that balance.
Right. And there was a question about shore power is a relatively mature technology and widely deployed in Europe. Do you expect the same type of growth in vessel charging infrastructure as well?
I think that goes a bit
Maria,
back to
maybe you. Yeah.
I was just gonna make a quick comment. It goes a bit back to the comment in my presentation that shore power really was able to scale once we were able to standardize the connection, right? So a lot of these vessels,
the standardization is.
Yeah, exactly.
Yeah, I think from my perspective, I think we could hope that it will grow as well, but I think from our side, it's all about the volume, and as of now, there's not that many vessels that are able to connect. So trying to find a viable business case, building this infrastructure at this time, I think it's not possible, but hopefully going forward, we will see that. So I think we will continue focusing mostly on shore power, but if we have cases where it's possible to use different technology, we obviously will try to do that as well and allow for charging. So yeah, I think the market will have to decide the speed.
Okay, there is a question from Volvo, Devradut from Volvo, who is asking, do you generally use two cables, one for shore power and one for charging of the boat itself? Maria, that's maybe also a question for you, then, where you have onshore power supply and at the same time battery charging, where the charger is not on the vessel. Yeah,
so definitely, if the charger is not on the vessel, it won't be able to charge via our shore power system. Then it will have to be a separate charger with the charger on the shore side. So then it will have to be two different things. So yeah, I don't know if I've answered the question correctly, but yeah.
Then there is again a question about corrosion. Stray current from the grid due to maybe not so good earthing, will that increase the corrosion?
Yes, yeah, especially with DC. Yeah, AC much less, but especially on DC.
Okay, I'm going through the questions here. So yeah, stray currents. Yeah. Okay. Then you will be. All right. So there's a question from Robert the Monk, who is asking, at the moment we are using lithium-ion chemistry. What is your vision when we will be moving towards solid-state batteries? Will that be a big game changer for the marine industry?
Yes, I think that's maybe something for me. I think at the moment there's still a lot to improve in the types of batteries that we're using. At the moment you see that the NMC chemistry of lithium-ion is the most popular, but just like in the automotive industry, also the maritime industry is looking more into different solutions like LFP, LTO. And it will not only be solid state that will be the most interesting for us. Also, for instance, sodium-ion batteries can be a solution for in the future. And when we will see these new technologies being installed on board of ships, I expect them to be going to the automotive industry first, because it's a much larger industry with a larger demand for batteries, and then we'll see them later in the maritime industry.
Yeah. Jason, plug and charge. We know it exists in the automotive industry. In Europe, in Korea, it's already going to be big. Is it something you see happening in the marine industry? Is it something that Plugport will be able to use in the future all over Scandinavia?
I say I hope so, based on the assertion that using the vessel as a secure endpoint instead of using and eliminating things like credit cards and RFID cards as much as possible when charging, from a cybersecurity perspective, is a much safer and secure way to be able to conduct a lot of charging. I think the costs of something going wrong with all of the different powers. I mean, we looked at all of the different multiple inputs that ships take right now. With all of those different inputs going on, like having a real secure trust between the vessel and the charger, with, of course, the support of the back-end infrastructure that support them, and also authenticating the owner of the boat or the captain, that would present a much more cyber secure platform on which to grow the business.
Maria, at this moment, how do your customers pay?
So for the charging for the smaller boats, we have an app basically that they use, but they need to register either in the app, or they could also use our RFID app at the moment. But definitely we would very much have liked, for this to be an automatic system, so that we could recognize the boat and then the owner, and it would just be fixed from the back end. Well, that's where we're going, I think. I agree, Jason. Yeah.
And then I have, I have a last question from my end, is climate change. Will this affect anything in the today? Are you already thinking what is it going to be in 10 years time in the harbor? What type of equipment should I be installing? Should I prepare myself for higher tides, lower tides, or is that not yet? Is that not still something far away in the background? It's very far away.
So when we're planning to build any type of infrastructure, shore side, we definitely have to think about how things are going to look 10, even some places we have to look 100 years from now, because so it depends on the regulations of the area, and if we are supposed to be allowed to build something, we need to kind of show that we have thought about this. So it needs to be elevated in order to also take care of higher tides going forward. And also definitely infrastructure-wise, we also need to build something that could be used today, but hopefully also as flexible as possible, so that it will have value also going forward. So yeah, it's about thinking about the future, but obviously it has to be something that we can use today. So and also being a commercial player, we need to make it commercially viable as well. So
I think it's a question, an agonizing question that we all have to deal with. Certainly, it's just like EVs. If there's more EVs, if there's more e-vessels out in the seas or in the water, certainly they will emit less carbon footprint. But and the charging infrastructure will inevitably build up. But how are we going to generate the electricity needed for all of these massive machines? So I think that's something that we still need to work on together to make it a greener future.
Yeah. Yes, Dan. Dan, cannot hear you.
Ah, it's muted. It was a great speech. I have two ways to mute it, so I was looking at, okay. But no, so to add to Jason, I think how we generate that power, I think that's not the main challenge. If you see that it's something we are doing it quite well. And I think what we're doing by electrifying all these vessels, it really supports the transition into renewables. And then we need to have smart charging algorithms. So we need to do a certain way of energy management to make sure that what we generate, if there's a lot of wind or a lot of sun or not, how do we make sure that everything is being charged in the right way? So software becomes even more important. Smart charging algorithms become more and more important. So really looking at the entire ecosystem. But I think this exactly, it fits into the transition that we're making. So I think in that sense, we're really excited with ABB. So you get bigger consumers from passenger cars, trucks, buses, anything, and there will be big demand. Battery or energy storage will play a huge role in this, but it really is an enabler to moving towards a more renewable and greener, let's say, future. And I think, Jacques, to be honest, we have something in our hands to really contribute to avoiding that we have these big changes in sea level. So let's make sure that we put a lot of chargers and a lot of electric vessels out as soon as possible, so that we contribute in avoiding. I always heard it's better to prevent instead of cure. So let's see what we can still do to prevent things.
Yeah. All right. So I think this is the end of our event. I would like to thank you all for taking out the time, sharing your ideas and your thoughts about e-mobility on water as a success, but also make the future better and cleaner. The last point I wanted to mention is that the marine topic is not yet off the cards today. This afternoon, the IEC 8005 Joint Working Group 28 will be coming together again and discuss about charging in the marine industry. And another topic, which is not on water, but in the air, is that today and tomorrow, CharIN is giving presentations on MCS at the Electric and Hybrid Aerospace event in Frankfurt. So there's a lot of things happening with MCS, and everybody is jumping on it. So Dan, I think you're going to have to work more than 8 hours a day, 7 days a week to make it all happen, because everybody's pushing. When is it happening? When is it coming? So the future is bright for the charging makers.